Hello, thank you for attending this presentation. I'm Simone Leonardi, and I'm going to talk about the research paper entitled Mining Microinfluencer from Social Media Posts. This work is in the KLP track for SAC2020 conference. This work is brought to you in collaboration with Politecnico di Torino and Links Foundation, with the support of Diego Monti, Giuseppe Rizzo, and Maurizio Morisio. You can contact us with the shown email addresses. I will talk about microinfluencers because they have a huge social impact, thanks to their persuasion skill and their ability to inspire trust in their community. These conditions lead the audience to reinforce or change their mind and behaviors over a specific context. An important characteristic of microinfluencer is that they are less famous than standard influencers. In fact, it is much harder to identify them among the noise of social media environment and through the abundance of data and information. Anyway, being less famous allows them to be very engaging when they interact with their followers. Suppose you are looking for an advice for a travel, or maybe a scientific paper useful for your research, or when you need to buy a tool. Who do you ask for an advice? People in your community that you already know and possibly you had a long conversation with in the recent past time, or a celebrity that is able to reach millions of people but that cannot answer to you directly? Currently, metrics and scores related to influencing people are mainly based on network structure and disease spreading. They are usually based on number of followers, centrality in the community, so related to the number of nodes and edges in the social media graph. We propose the analysis of personality traits and community values extracted from social media posts in the form of written text produced by microinfluencers. We consider influencing people from a linguistic perspective. We used two models based on personality traits and community values to highlight these aspects. The first model we adopted is based on individual personality traits. It is called Big Five, or five-factor model, or OCEAN, due to the 5 traits it considers: openness, conscientiousness, extroversion, agreeableness, and neuroticism. We work with the Twitter platform. Starting from a user tweet, we clean it from stop words, URL, handles, then we performed lemmatization and stemming. Once cleaned, we retrieve the pre-trained word embedding from fast text for each token. We computed the sum, max, mean, average of each dimensions of the whole word embeddings for a single user. We concatenate these 4 embeddings, and from these we predict and estimate the 5 personality traits. The evaluation step is possible because we previously extensively tuned a supervector machine model on my personality gold standard to perform the regression. My personality dataset has been created by Kosinski thanks to a Facebook application that paired user posts on Facebook to their answers to a psychological questionnaire that compute their personality traits. These scores of the 5-factor model are in a continuous range from 1 to 5. The second model computes community values. We adapted the basic human values model by Shalom Schwartz. Here, each individual is considered as belonging to a community with which he shares human values. As you can see in the image on the left, we replicated the initial steps of tweet cleaning and tokenization from the previous model. Then, for each token, we retrieve the related pre-trained word embedding from Globe vocabulary. This vocabulary is tuned on Twitter and more effective on short text. Here, we developed a score mechanism based on Euclidean distances. Basic human values research gives us example words for each human values. Self-direction, stimulation, hedonism, achievement, power, security, conformity, tradition, benevolence, and universalism. We created a centroid per basic human value, averaging embeddings of words given as a sample. Each token in user tweets is assigned to the closest centroid in terms of Euclidean distance. Once all tokens have been processed, we multiply the total number of words used in a community-based value per the inverse of the Euclidean distance between the example centroid and the averaged centroid of the words used in that semantic cluster. At the end of this process, we obtain 10 basic human values scores per user. The gold standard has been made out of the collection of 2 million tweets among more than 1,000 users and over 12 topics. This dataset is available on FigShare website. Add the link in our paper. You can also find the link in the slides and in the details section under this video on YouTube platform. For each user selected as potential micro-influencer, we computed these 3 scores. They came from previous research works in the field of influencer and marketing, customized and adapted for the case of micro-influencer. The first one, called embeddedness, is inspired by the work of Heasley and Kleinberg in their book Networks, Crowds and Markets, Reasoning about a Highly Connected World. It is a measure of virality. If 2 or more influencing users inside the same community reinforce a message, it propagates faster. We measure this score counting how many followers of a candidate overlap with other candidate followers. The second score is called interaction. It is inspired by the interactor ratio of Hanger and Kittel. It is important to notice here the focus on follower and not other users. In fact, we want to measure the ability of the candidate to influence its own community and not other users. The third one is the engagement score. It came from the commercial grain tool, and it is a standard measure of virality that sums up total number of likes and retweets for each tweet weighted by the number of followers and tweets. If a user embeddedness, interaction, and engagement scores are above the average scores among the other candidates of the same topic, they are labeled as micro-influencer. As we expected from the beginning of the experiment, the number of micro-influencers is very low. This condition led to an unbalanced dataset. In this figure, we can analyze the whole process from the beginning to the final classification. We start performing a query to Twitter asking for English tweets having as a hashtag a desired topic. As an example off-grid, from the list of tweets we received, we extract the users that posted them having a number of followers ranging from 1,000 to 100,000, and having number of followers greater than number of followings. This is done to filter fake profiles or users that follow everyone to be followed back. We remove duplicate users and we create the list of potential micro-influencers for that topic. We then retrieve the information associated to each tweet and each user to compute embeddedness, interaction, and engagement. And we created the gold standard applying the average threshold mentioned before to say if a user is a micro-influencer. For these potential micro-influencers, we compute personality traits and community values, starting from their whole written production on Twitter. Then, we use the personality traits and community values as input features for a classifier, and the micro-influencer label as desired output in a supervised binary classification case. We experimented various approaches to classify micro-influencer. The first is the best performing one. It is a support vector machine with a radial kernel and having gamma scale parameter. We also tested a random forest with a max depth of 15 according to the sum of the 5 personality traits and 10 community values. The third choice is a convolutional neural network with 2 dense layers with a ReLU and a sigmoid activation function, with Adam as an optimizer and a binary cross entropy as loss function. The last model is an ensemble method, able to choose the best algorithm among the previous according to each case in the dataset. In order to compare obtained results with these different approaches, we used a stratified key fold with k equal to 10, and we compute the precision, recall, and F1 score. We gave much weight on the positive class, so to micro-influencer, because it is what we want to identify, and because of the unbalanced dataset. To do so, we used a parameter called the class weight to redefine the weight of positive sample according to a 1 to 10 proportion. We select the support vector machine because of experimental results, and we focus mainly on recall because of the information related to our context it will enhance. So, results are saying that we predict more micro-influencers with respect to the effective ones. But it is fine, because we want to find the few existing micro-influencers, even considering the possibility to discard non-micro-influencers falsely predicted a posteriori. The technological novelty proposed is the adoption of linguistic features with personality and community models to better describe and identify micro-influence. In conclusion, we created a gold standard in the field of micro-influencer and described a procedure to further expand for other topics. We used natural language processing through word embeddings to compute both personality traits and community-based values of candidates and the micro-influencer. As future work, We will analyze also emoticon and other features available in social media posts. We want to enhance the definition of microinfluencer, searching for a wider and shared one. We want to create a shared repository to collaborate with institutions to promote a positive social impact, leveraging microinfluencer capabilities. You can find the code of this work at this link, while the dataset both in the description down below, in the comment section of YouTube platform, or in the paper. If you have questions or comments or suggestions, please post them down below in the comments area or write me at the institutional mail. Thanks for your attention.